Hi, everyone. Thanks so much for joining us today. As everyone jumps into the Zoom webinar, we'll give everyone a couple minutes to join. Sorry, we're starting a couple minutes late, but we have a good hour packed of content today. So thanks everyone for joining. We'll kick off the conversation with our CTO and head of product in just a minute or two as we keep people some time to join. All right, I think we're going to go ahead and get started since we're a little bit behind. So welcome to our first webinar here at Fingerprint. We are going to be discussing why accuracy is everything in device identification today. Hello, I am your moderator. My name is Courtney. I'm here on the marketing team. We'll go over some couple quick housekeeping notes. If, as we're going through our conversation and our content today, you have any questions or any comments, feel free to utilize the Zoom Q&A and the Zoom chat, and we will be answering some questions live at the end. And we'll go ahead and talk a little bit about what we'll be covering today. We're going to talk a little bit about our overview of our accuracy and our products, some challenges and misconceptions, and talk a little bit about some practical applications of that in fraud detection and in growth. And then we'll have some questions and answers at the end. So I'll go ahead and I'll hand it over to our wonderful guests today to go ahead and introduce themselves.
Hi, everyone. I'm Valentin, co-founder and CTO of Fingerprint. Started the open source Fingerprint library in 2012, and now working as a CTO.
And hi, everyone. My name is Jack Spirou. I started the first half of my career really as an engineer, and then the second half of my career I've been working in product, and I've joined Fingerprint as the head of product. Moving on, and we'll just jump right into the content if that works for everybody. So Valentin had mentioned just a little bit ago in his introduction that he had started work on Fingerprint and Fingerprint's history back in 2012. And so we kind of have a great, storied history on our open source and how we built an open source community really around our company. And so Valentin, if it's okay, could you tell us a little bit about that history and how Fingerprint started really, and how we built that open source community around us?
Yes, FingerprintJS, the library was started in 2012. Then I worked at a company that sold online gift cards, online coupons, and we saw a lot of fraud there. We saw people like buying a lot of gift cards and reselling them. There were bots. There were like essentially a lot of nefarious bad actors that abused and tried to buy as many coupons as possible. So we needed a system that would be able to identify customers and end users of the website to be able to do fraud detection for them and identify cases where those bad actors would buy a lot of gift cards or coupons. And the idea itself came from research papers that I read. My main goal or objective was not to depend on IP address or cookies. And I decided to create a system that would fingerprint a browser by collecting a lot of signals, many signals, as many as possible, such as fonts, screen resolution, installed plugins, and many more. And combine them into a single ID that was called browser fingerprint. And this idea turned out to be very successful. The project was picked up by a lot of websites, and a lot of top websites by traffic are using it. 12% currently, top 500 websites by traffic use the open source library. So yeah, that was the background of the Fingerprint open source, FingerprintJS open source.
Awesome. And then as folks may know, not only do we have an open source offering, but we also have our pro offering. And our pro offering, we tout a great accuracy metric, right, which is 99.5% in terms of our accuracy. And this is a number that we get a lot of questions about. And a lot of folks ask us, well, how do you come up with this 99.5? It almost sounds too good to be true. Could you explain it to us? Could you explain how, in fact, you reach this high level of accuracy? And of course, that's the webinar the topic for the webinar today, right? This is what we're talking about. We're hoping to shed a little light about today. So with that being said, in order to explain our very high levels of accuracy, we need to actually talk a little bit, not only about accuracy as it comes to fingerprinting, but also a little bit about our products as well. And so we'll give a little bit of an overview of our products as they relate to accuracy. And so to start, as we dive into this topic, I think it makes sense for us to ask, what do we really even mean by accuracy? So how do we define the term, and why does it matter? So Valentin, if you could explain a little bit about when we use that term 99.5%, what do we mean by accuracy, and why does it matter?
Sure. Accuracy is a single number. It's a percentage number from 0 to 100. It's how many of your returning visitors you can identify. Every website has new visitors and returning visitors. And when returning visitors return back to your website, you want to identify them for like various purposes. And it's that percentage of how many you can identify successfully is what we call accuracy. If you have 10,000 visitors to your website per day and 9,000 of them return in the next month, and you are able to identify 99.5%, it means you can identify 99.5% of those returning visitors to your website. And when you do that, of course, you can attach very interesting like information to them, like what they did they perform any fraud or not, and you can associate that information with those identifiers. And that's why we pay extra attention to this accuracy number. And the main goal of our product is to have the highest possible identification accuracy in the world.
And so that's a great jumping off point, because we really have a few products that we deal with when it comes to accuracy. One of our products we've talked a little bit about, right, is the Pro version, where we have that 99.5%. But before we get to Pro, the other product that we talked a little bit about earlier is our open source offering. So we do have that open source offering. So when we think about our open source offering, what is that accuracy? Obviously, we talked a lot about 99.5 for our Pro, but how does that compare to our open source?
Sure. So open source is a very popular project. It has over 16,000 stars on GitHub. And the way it works is it collects browser signals and hashes them, combining them into a single fingerprint. And a few words about how it works first. It's a JavaScript library. It means it doesn't make API calls. It doesn't need a backend to work. It completely exists only in your browser on the client side and doesn't need to talk to anything else. The accuracy of the open source is approximately 60%. And I would like to explain deeper what it means. Accuracy depends on multiple factors, but most importantly, in case of the open source library, it depends on what type of browsers you use with it. For example, if you use Android, like Google Chrome on Android or desktop, the accuracy will be much higher, around 70, even 75%. But if you use iOS or macOS or Apple TV, any Apple operating system, the accuracy will be much lower. As low as 30, 35, sometimes 40%. Combined, if we take real life kind of traffic proportions, combined, the accuracy of the open source is approximately 60%. That's what we are observing, and can vary depending on your browser composition, what kind of traffic you have, but overall it's 60%.
So that's a fairly wide gap between 60% and 99.5%, which is what we talk about for our Pro or our paid offering versus our open source and free offering. How do we close the gap from 60% accuracy to 99.5?
Yeah, so when we started designing the Pro version of the product, we realized that just having the product live in the browser isolated will not get us any more accuracy. And we realized that we need to introduce a backend to be able to collect additional signals and perform some data analysis on the data that we collect. So one important thing that I'd like to touch on is the Pro, Fingerprint Pro is built on top of the open source. It has this open source as a foundation on which it builds, but it adds so much more on top of it to be able to achieve that greater accuracy. So as I mentioned, open source exists in the browser, runs purely on client side. The Pro version adds a lot more new signals to it. So it doubles the number of signals. Open source has approximately 30 to 40 signals depending on the situation. By the way, we constantly kind of revise the active signals in the open source to make them current, make them up to date, and have them provide good performance and accuracy proportion or balance when running in the browsers. But we had to double the number of signals in the Pro version running in the browser to be able to collect more entropy and collect more information about the browser. Then we send that information to the backend. And backend, before it stores that information, it needs to perform some additional signal collection, such as IP addresses, URLs, referrals, some crypto analysis of your TLS stack, some maybe TCP IP fingerprinting, etc. So it collects additional server-side signals that don't exist in the browser, but they exist on the networking layer, on the encryption layer, on the server-side layer, and it adds those server-side signals to the kind of wider collection of signals that it collects. And then it stores all the signals in a database and performs machine learning data analysis on top of it to be able to reliably deduplicate similarly looking devices and reliably find older fingerprints that it collected months or even years before. So the backend component is critical in increasing that accuracy, in addition to, of course, increasing the number of signals in the front end. So for the backend, the accuracy is achieved not only by collecting signals, but storing reliable identifiers. We have multiple redundant mechanisms of storing reliable identifiers. We generate unique and random numbers and store them in local storage, cookies, and other techniques, so that when those identifiers are available, we use them. If they are not available, then we kind of fall back to fingerprinting and server-side analysis to be able to find the visitor ID that the backend stored before. So it's kind of like a graceful degradation of the process and fallback process. Start from reliable identifiers that are frequently available, and we just need to read an identifier. But if it isn't available, we fall back to the server-side fingerprinting and return the visitor ID back to the client that's 99.5% accurate.
So the complexity of the problem is fairly large, hence why we see this layering of capabilities that you just talked through, which create kind of a funnel for us to go through in order to make a good connection or reliable identification. And so in the wild, whether it's customers' perception or whether it's actually using this technique with users in the field, what are the misconceptions that we see when it comes to fingerprinting accuracy, given that this is a complex field?
Yeah, there are a few of misconceptions related to browser fingerprinting and browser fingerprinting accuracy. The main that I like to highlight is that browser identifiers are browser scoped. So we identify browsers and generate visitor IDs per browser. They're linked to the browser. We get a lot of questions. Why don't we generate a device ID? The reason we don't do that is because we dive really deeply into each browser source code, like implementation details, and thus are able to extract a lot of valuable signals from that specific browser instance that are not available on the device or platform level. And this way, when we look really deeply into each specific browser, we collect 2 or 3 times more signals, very accurate signals on the browser level, and are able to generate that identifier per browser. So other companies try to generate a device level ID, but I think our approach is better because I would prefer to use 2 or 3 very accurate identifiers instead of one that is not really accurate, like 60% accurate. The reason for that is if I need to decide, like in my fraud detection or fraud prevention logic, I can just keep track of all the browsers the user has, for example, Safari and Chrome or Safari and Firefox. So I'll be working with 2 identifiers instead of 1 device identifier. But those 2 identifiers will be so accurate that I could rely on them and make my logic build on top of them. That's why my preference is to have 1, 2, or 3 very accurate browser level IDs rather than a single, not really reliable device ID. Makes
sense. So far we've discussed a little bit about our open source product. We've talked about our Pro product. We've talked about the accuracy differences between both, so 60 to 99.5. And of course, this whole webinar today is about accuracy and about that 99.5% number. And so hopefully we built up enough context. We've talked a little bit about our offerings, but also about what the misconceptions are when it comes to accuracy with that 99.5% number. And so with all of that background and context, hopefully we can answer the main question of why we're here today, which is how do we calculate that 99.5% number? What is the reasoning and the mathematics that we use in order to get to that 99.5% accuracy?
Yeah, that's a great question. That's the core question of this webinar. How do we calculate the accuracy and how can we guarantee that the accuracy is exactly that? You can see this formula, but I'd like to unpack kind of this formula and explain it using simple words. So first of all, we run accuracy measurement in real time for every single API call. Every single API call that we receive, we always try to measure how accurate it was. And the way we do it is, I mentioned before, we store reliable identifiers in the browsers, local storage, cookies, etc. Those are random and unique IDs. When we get that identifier into our system, and for some customers, the number of events or API calls with those unique IDs is really high. So we use them as a baseline, as a ruler to measure the identification accuracy. So when we receive a reliable ID, in parallel, we perform the fingerprinting identification. And then after the fingerprinting identification gives us back the visitor ID, we compare this visitor ID with the reliable identifier that we got from the local storage, let's say. So the reliable identifiers are 100% accurate. They are guaranteed to be unique, guaranteed to be permanent, guaranteed to be 100% accurate. We compare what we just found through browser fingerprinting with a reliable identifier, and then see if those IDs match. It's a true positive identification. It's the correct identification. If they don't match, it means it's a misidentification. It's where the 0.5% of the misidentified events come from. It's from the event where the browser fingerprint does not match the reliable identifier. And in this case, we need kind of to fork into two if-else statements, essentially. If it does not match and matches someone else, some other browser, it's a false positive error. If it does not match and it was just generated, it's a false negative error. It means the system wasn't able to find this browser and generated a new identifier instead. So this is how we measure accuracy for every single API call when we have a reliable ID associated with it, which is run a secondary parallel background re-identification, compare the results, and thus we can collect statistics over time, how many times the identifiers matched, how many times they didn't match but belong to different people, and how many times they didn't match but were generated from scratch. And this is how we get full true positive, which is 99.5, false positive, and false negative.
Great. So we talked a little bit about the way that we get to the 99.5% number, how we calculate it, how we maintain it. But when customers come to us looking for a solution, usually to fit their needs of their business case, whatever it might be, the problem that they're trying to solve for their particular business, almost always they say, great, you have this 99.5% number, but how does that number really behave over time? So how does your accuracy behave, say, 5 days from now, a month from now, 60 days from now, 90 days from now? How can we think of accuracy and its behavior over time for our use cases?
Yeah, it's a great question because technically the accuracy is a function of time. The more time passes, the less accurate identification becomes. And it makes sense. For example, if your end user visits your website now and then visits it again in just 2 minutes, very likely almost everything, every single signal will be identical. And we can re-identify that visitor with a very, very high accuracy. But if that end user visit your website today and then visit your website 3 or 4 months from now, then the accuracy will be slightly lower because some of the signals may not match, such as IP address or some other signals. Maybe the browser has performed an upgrade or even an operating system upgrade happened during this time. So the number of signals slightly drops that we can match. Thus, the accuracy drops over time. So we call this situation identifier drift. And this is one of the key topics that we'd like to talk about in this webinar as well.
And so that drift or that change in signal value over time, or that change from signal to noise over a longer extended period of time, that drift metric, if you would, is something that we rate ourselves on. But it's also, I think, a great way for us to look at the differences and competitive advantages we have between our product and what our product and capabilities can bring to the table versus our competitors. So can you talk a little bit about our drift and that metric of accuracy over time versus some of the competitors that we have, and kind of how the function or behavior of that drift really behaves for us versus our competitors?
Sure. Yeah, drift is a big problem in identification, and the lower accuracy you have, the bigger it is of a problem for you, because drift has a compounding effect on your identification. It means if you start initially from a 60% baseline, and then after 1 month is actually 36%, because of the drift, you get 60% out of the 60% in 1 month. And 3 months from now, you end up in a situation where your real identification accuracy is only 15% or 10%, depending on your traffic, because the drift compounds on itself and kind of eats away your accuracy each month because of the accuracy problems. In our case, because we start with a very high baseline of 99.5%, the compounding effect of the drift is very, very low. It is true, it follows the same principle. Each month, the drift will eat away from the accuracy, but because it eats away only 0.5% from what it was before, the actual drift after 3 or 4 months will be like 2%. So the accuracy will remain at a level of approximately 98% even after 3 or 4 months. And this is what you can see on this chart. This is based on real situation from our customers. We see that the higher baseline and lower drift contribute to a very little compounding effect over time, contrasted with a very high compounding effect that some of the competitors have, because their baseline was not as high as ours. So this is a very important distinction about why accuracy matters, because over time, that tiny difference in accuracy creates a tiny difference in accuracy overall. But if you start with a lower accuracy, over time, this really degrades your accuracy to 10, 15, maybe 20% if you're lucky after 3-4 months.
So we've talked a little bit about our Pro product. We've talked a little bit about our open source product and how it relates to accuracy. And it's been, I think, a decent overview so far. We've gone through calculation and now drift. But inevitably, a question that comes up for folks, especially as they are expanding their use cases, is, we've talked a little bit today about web, right, for the most part, and web apps. But what about beyond web apps? How can I think of, fingerprinting and device identification beyond just web applications, where it's, say not just desktop, but then mobile devices and mobile apps as well? And I know recently we've had a great change here, a big exciting change here at Fingerprint since the weekend. And can you talk a little bit about how this relates to that change that we had over the weekend?
Yeah, it's interesting that you asked and mentioned that. Indeed, we changed the company name from FingerprintJS to fingerprint.com. Now, you probably noticed we are on a new domain and have a new name. That's because we have outgrown the JS. We introduced, early on, we realized we need mobile device SDKs for reliable identification. So when the Pro version was started, we also started building the Pro libraries and SDKs for mobile devices. Currently, we support Android, iOS, and iOS, macOS, iPadOS, and we will also plan to support Apple TV in the future. So for these two main platforms, we have fully native SDKs, and in addition to that, we have developed cross-platform frameworks, framework integrations for Flutter and React Native, so you can build your native apps using any of the integrations that we provide. And accuracy is very different in mobile devices because we use native SDKs that have access to a lot more signals, a lot more information, but most importantly, we have access to platform identifiers. And these platform identifiers make all the difference when it comes to mobile devices. Instead of collecting hundreds of signals from the web browser, we can collect more reliable platform identifiers from mobile devices and use them instead. and the accuracy is actually higher than 99.5. It's almost 100%. But the key difference is because we use platform IDs, we identify devices now, not browsers. So I just want to highlight that difference with the browser and web, where we generate browser-specific identifiers. With a mobile device, we generate device identifiers. So if you use our SDK in several different applications, the identifier of the device will be the same. Even if you reinstall the application, the identifier will be the same. So that's a really important kind of distinction between web and mobile. It's a device level identifier that's even higher accuracy than 99.5.
Great. So we talked a little bit again about our Pro product, our open source product, the accuracy on both, and now the capabilities we have in terms of not just web, but then also mobile applications, and hence the name change that we've had over the weekend, which we're very excited and proud of. And with that being said, with so much going on, with so many platforms and everything that we're maintaining, how do we ensure that as browsers change or as the landscape of the internet changes, that we're continually improving that accuracy, or at least at minimum maintaining it? And of course, this is very important given the drift problem that we talked about earlier, because if we don't maintain those levels of 99.5% accuracy, we could see compounding effects of error rates that could get out of hand. So what does our engineering team do in order to maintain those levels?
Yeah, it's a great question. And I think the key thing here is Pro product is built on top of open source. We do not maintain open source kind of secondary. It's not a second class product. It's the foundation that we built on top of. That's why open source development has the highest possible standards in our company, like in terms of code review, testing, really high standards, because we know every single Pro customer will be using our open source. It's really important for us. We try to do two things. First, we regularly release updates to web and mobile as we see new platforms coming out. So the prime example here is Google Chrome. They release so much, so frequently. Their release schedule is crazy, but we keep up with that release schedule. We essentially are trying to sync our release schedule with Google Chrome release schedule. So whenever there is a significant change or significant Google Chrome release, we always release an update to open source and Pro to be able to match all the new capabilities or restrictions specific in this Google Chrome release. So technically, we release approximately 20 to 30 releases per year. So sometimes we make a couple of releases per month, sometimes one release per month. But overall, yes, we release 20 to 30 for both Pro and open source because they're kind of linked together in a single product.
So hopefully we've answered some questions today on accuracy, how we calculate our accuracy, how we think about our accuracy, how the accuracy changes depending on the product that you might be using. And to go back to that 60% versus 99.5%, that gap that we talked about before, if we were to make it real and think about actual use cases, right, that the customers come to us with, and specifically if we look at fraud detection, since because fraud is such a heavy use case for the customers that are leveraging our Pro product, what is the difference in outcome, in business outcome really, when it comes to fraud between that 60% accuracy, say for open source, and then again, all of the refinements that we've made and all the effort that we put in to build that to 99.5? What are the tangible outcomes for customers in their business when it comes to fraud detection?
Right. Yeah, the increased accuracy is very important because it allows to trust the identifier so much more and makes some use cases possible that were not possible before. With a 99.5% accuracy, you can actually work with use cases such as account takeovers, e-commerce fraud, refund fraud, chargebacks with credit cards, very important use case, cryptocurrency exchanges and money transfers, all kinds of bad actors identification and user banning, spam, a big topic. With these increased accuracy, you can actually rely on the identifier to make automated decisions. You don't need to look at IP addresses. You don't need a support team or risk fraud analyst team to be able to confirm every single transaction. Instead, what you can do is you can automate the whole thing and process every single transaction in your system with Fingerprint Pro. Sorry, I still keep using FingerprintJS because that's kind of ingrained in my memory, but now it's Fingerprint. So the automation and reliability and trust of the identifier is key here. Any high volume scenario that wasn't possible before because it would just mean a lot more work, just impossible. With Fingerprint Pro, you can automate all that and rely on that to be able to introduce Fingerprint Pro into your machine learning models, your risk scoring models, your transaction review models, and automate all of that without needing human intervention. So that's the key differentiator between low accuracy identifier, where you kind of need to confirm that because you're worried about false positive, with the pro level identifier where you can automate all that and rely on scaling the process instead of manually processing them.
And so what's interesting is we've seen our customers really not only leverage this very high accuracy rating for fraud and be very successful there, but they've been so successful in the fraud space that now we're starting to see customers actually use our accuracy of 99.5% in other spaces, in other ways to enhance and enable their business. And one of the areas of which, and we can maybe talk about a couple of use cases, and if you could add to this, Valentin, and talk a little bit through what we're seeing customers do in the growth space. So how are they using the 99.5% accuracy rating now, not only for fraud, but also for growth?
Yeah, it's actually interesting to see all the novel use cases that we see from the open source community. When we started working on Pro, we didn't realize that so many use cases are possible. But because the library is open source, we see a lot of questions from customers using Fingerprint open source in different use cases. And one of the new ways that we kind of seeing the Pro product being used is account sharing prevention. It's when you can detect when someone is sharing their account. Let's say you have a very expensive subscription for a professional service that you sell, like a SaaS business. Someone bought a subscription and shares that with someone else, or what's even worse, can sell their credentials to a large group of people, and you're losing your revenue from that person. So what you can do now with the Fingerprint Pro is detect all those sharing accounts and detect those accounts, those users to whom the credentials were shared, and market to them so that they would actually buy the subscription directly and increase your ARR. Another interesting new use case that we're seeing is personalization and recommender systems for e-commerce, large businesses in online sales. Really important. You don't need everyone to have an account on your website. Let's take Target.com, for example. You can have anonymous users visit the website, and you can provide recommendations and build a kind of recommender system on top of the Fingerprint Pro identifier to show them items that they're interested in and increase your conversion rates, of course. And another novel use case is attribution. It's both web attribution for marketing and mobile attribution, like for app installs and stuff like that. Really exciting use case.
Yeah, and I think we've seen the e-commerce and personalization capabilities really take off. And I know from I have a background in e-commerce and large e-commerce companies as well. And I can say these kind of personalization techniques really can enhance the business and really create new untapped sources of revenue to some degree with this level of identification. And that kind of gets us into this pattern that we're seeing, which is, folks have really grabbed onto that 99.5% accuracy, leveraging it for their business, to start with fraud, but then also moving on to growth. And one of the things that we'd like to offer today to everyone who's on the webinar is the ability to review our product roadmap and what we're doing. And so where we're taking this 99.5% accuracy next, and all the different features and capabilities that we're building around it. So I believe someone will share, or Courtney will share a link in the chat so you guys can get access to our public product roadmap. Please feel free to review it, take a look at it, comment. You can vote different ideas up and down, other things that are under consideration or planned. We're happy to chat with you and take feedback on the new features and capabilities that we're building onto our product around this 99.5% accuracy. And then finally, of course, in the upper right-hand corner, if you think there are items that we've missed or things we haven't thought about or things that are important to your use case or things that you're looking for to enhance your business, please submit an idea to us. Go ahead and share that use case or submit a new feature request or idea with us as well. And we'd love to review it. And who knows, if you're open to talking or or communicating a little bit about why that's important and how we can make sure we're solving that problem effectively for your business, we'd love to have those conversations as well. So with that being said, I think I'll hand it back over to Courtney. I think probably next we'll go through question and answers. Thank you, Courtney.
Thank you so much, Jack and Valentin. That was great. Great conversation. We had some really great questions come in throughout. So I will start at the top, and some of it may have been kind of covered, but I want to make sure we get everyone's questions answered. What if an HTTP client is not a browser example, a scripted bot? Will you be able to ID it as well?
Yeah, so for HTTP and application requests, these are better to handle by things like API firewalls or web application firewalls that can operate on like HTTP header analysis or TLS analysis and block those requests. For example, if you have a large attack created using Python, or someone is like making a lot of requests with curl or wget, you can detect those easily as not a JS-enabled browser, but more like an HTTP agent that you can block using your WAF rules or your web application firewall, etc. We focus on users, real humans, using real browsers to perform fraudulent activities. And we think a layered protection would make sense in this situation, where you first have a WAF that would filter out all the programmatic API requests first. And then for humans using browsers, WAF cannot do anything there. It will allow them to continue accessing your website. So then you need Fingerprint Pro to be able to identify those users, real people using real browsers, to attach like if they did something bad with your website, you can attach that meta information to the visitor ID and use that later to be able to block this user or step up your authentication, like show a capture, anything that makes sense on your website. You can do that only for a small proportion of users that perform like nefarious activities on your website. You can leave the rest 98-99% of your users alone, have zero friction for them, but for this tiny amount of users, you can kind of step up the protection using Fingerprint Pro. And that's how I would kind of layer the protection on your website.
Thank you. So the next question is, there's a sentence for context. The same device on different browsers would have the same device ID. Device ID should represent a unique identifier for every device. How many unique devices do you have in your database, or in your backend database?
Yeah, we process approximately 1 billion API calls per month right now, more or less, depending on the region. And we support multiple regions. So the main region is USA. We also support EU Frankfurt region and Asia Pacific region. So in the US, for example, it's approximately 1 billion API calls. So it depends per customer. So globally, I would say you can divide by 3, by 5 the number of API calls. So it's approximately 200, 300 million device profiles if you divide the total number of API calls by the average number of API calls per device per month, and you get to 200 approximately device kind of profiles that we store in the database. 200 million, sorry, because the total number of requests is approximately 1 billion in one region.
Awesome. Thank you. And then the next question is, what is the percentage distribution of false positive versus false negative?
This question really depends on your traffic. So for some businesses, they almost don't have any false negatives or almost don't have any false positives. So it really depends on your return rate. So if you have a very, very high return rate on your website, it means the same kind of end users keep coming to your website, then most of the error rate will be in the false positive territory. But if you have a really high, really low, return rate, and you have new visitors coming to your website and old visitors not coming, then false positive will be lower and false negative will be higher. Great.
And then I've got 2 questions I'm going to ask at the same time. So one question is, has your Pro product always been 99.5% accurate? And then also for the Pro version product, how many features are in your machine learning model?
The product has always been 99.5% accurate. And the reason for that is actually browsers tighten up security all the time. And we need to continuously test new upcoming releases, Canary releases, Chrome beta releases, Safari technology preview releases, to be able to develop new signals and find new novel ways of identification, even though the browsers try to deprecate or remove some of the older leaking signals. That's why we try to maintain that level of identification quality of 99.5, even though browsers introduce like hurdles for us to make it difficult to identify. So I would answer this question, even though Safari introduced like intelligent tracking prevention and Chrome introduced like privacy sandbox, we are still able to maintain the 99.5% accuracy, but the level of sophistication has increased tremendously during the last 2 years because we keep investing all the research effort in maintaining that accuracy, despite browser tightening up the kind of privacy and security APIs around all the newest versions. So what was the second part, Courtney? Can you please?
Yeah, for the Pro version, how many features are in your machine learning model?
It's hundreds.
Great. And then it looks like we've got maybe one more question. So it says, starting with Android API 29 and iOS 7 mobile platforms, banned permanent IDs like Wi-Fi, Mac, IEMI, did it impact the accuracy of your mobile IDs?
It didn't impact. The reason it didn't is we never use just one identifier and rely on one identifier. We always create multiple redundant reliable identifiers and always introduce a fallback logic into those identifiers. We kind of fall back to the second ID if the first is not available, then to the third ID if the second and first are not available, and so on and so forth. So we kind of fall back to all the identifiers. And when we exhaust those identifiers, then we rely to fingerprinting. And this is why, even if someone removes a single identifier, let's say in a new major release, we are still able to fall back to some of the existing identifiers that remained or survived and maintain that accuracy. And with iOS, we use a keychain storage with platform IDs and fingerprinting in order to be able to keep providing that accuracy, even with application reinstalls.
Great. We had a couple more questions. It looks like we've got some time, so we're going to go ahead and get them answered. So from a little bit earlier, is 99.5% valid for native mobile apps as well?
It's actually even higher. So for most situations, it will be 100%, but sometimes there are like edge cases when a device manufacturer violates some of the like APIs that they consume from Google, for example, like and this sometimes leads to like different anomalies in identifier distribution, and these can, in a certain country or in a certain market or in a certain area, reduce the accuracy. But overall on mobile, because we use platform IDs, the accuracy is almost always closer to 100%.
Great, thank you. Next question is, can your Pro server be deployed in a customer DC?
We don't offer an on-premises model, unfortunately. We only offer a SaaS hosted version. However, we host everything on AWS, which has all the highest certifications, including government applications, and can deploy in government cloud when necessary. And we are SOC 2 Type 1 and soon to be SOC 2 Type 2 certified, so we meet the strict security and privacy standards. And if you need to like discuss with us like why you need an on-premise solution, for example, you can always reach out to our engineers to discuss like pros and cons of each and kind of walk through what would be the right way to use our API in a high security or very like environment where like maybe legal frameworks like in Germany, for example, require you to host it on your data center. We can always kind of work with you on those situations and decide what would be the best way to tackle those.
Great, thank you. Next question is there a way of telling whether a request comes from a real human or from an automated bot like a headless browser, for example?
There is. We have a bot detection product that's in beta. It's an open beta. You can join if you want. We are going to release it in the upcoming months and as a public generally available release. But if you want to play with it or put it onto your website, you can reach out to fingerprint.com/product/bot detection, generate a couple of API keys, and be surprised how accurately we can identify automation, Puppeteer, Selenium, Playwright, all those things we can do with our bot detection product that is about to release soon.
Great, thank you. And then I believe the last question now just came in is, do you collect PII in the Pro server?
We do collect PII. From a GDPR perspective, we collect IP addresses, which in some jurisdictions constitute personal identifiable information. We act as a data processor, so we don't control, we are not data controllers. We don't control how the data is collected or when the data is collected, at what circumstances. So as a data processor, we are GDPR compliant and CCPA compliant, even though we collect PII. For our customers who would be data controllers in this equation, we recommend obtaining user consent for PII processing in those jurisdictions where it's mandatory to have. So we do collect, however, we are compliant because we are a data processor.
Great, thank you. So it looks like that was our last question. I'd like to thank our guests for their time today and everyone that attended. We will be sending out a recording of this a little bit later this week. But if you ever have any more questions, you're more than welcome to reach out to our team. And thank you so much, everyone.
Thanks, everyone.
Thank you, everyone. Bye-bye.
Bye.